Today's webinar is part of a broader initiative known as the COSPACE Webinar Series, which brings together leading Horizon Europe projects to showcase how space-enabled innovations are shaping a greener and more resilient future. So COSPACE is a group formed of 5 Horizon Europe projects: Respondent, Magda, Swift, 100K Trees, and BuildSpace. And what these projects have in common is that they're all working on cutting-edge geospatial and AI-driven solutions to tackle climate change. It's supported by the Horizon Results Booster Programme, with COSPACE amplifying the impact of these respective projects by promoting knowledge sharing and collaboration. This is actually the first in a 2-part webinar series, with today focusing on the role of space technologies in energy and agriculture specifically, highlighting how Respondent and Magda are harnessing satellite-based forecasting, remote sensing, and AI to improve climate resilience. Our second webinar will take place on April 15th and will showcase the 100K Trees and BuildSpace projects, who focus on green cities and sustainable urban development. If you're interested in how space-based decision support tools are shaping future cities, be sure to register for that webinar as well. So why is this webinar important? Well, tackling climate change requires collaboration, innovation, and the smart use of technology. And I feel that's why today's discussion is so important, because both Respondent and Magda are at the forefront of integrating Galileo and Copernicus systems using AI-driven forecasting, remote sensing, and geospatial data to support energy security, sustainable agriculture, and climate adaptation. So in terms of what we can expect in today's webinar, we have an exciting lineup of speakers who will dive into topics such as how satellite-based forecasting enhances energy grid stability, the role of GNSS and Copernicus data in precision agriculture, and the broader impact of space-based enabled climate adaptation strategies. While we of course encourage everyone to participate and drop questions in the chat, there will be a dedicated Q&A session at the end of the webinar for people to openly discuss, ask questions, etc. So to get started, I'm going to hand you over to Effie Makri, a colleague of mine on Respondent, who is the project coordinator and is the VP of Research and Innovation at Future Intelligence Limited in Athens, who will set the discussions for today. Effie, whenever you're ready.
Thank you so much, Ben, and thank you everyone for joining this joint event. So thank you everyone for joining. I'm going to talk about the Respondent project today. And this is an outline of the presentation. So what is Respondent? What methodology we used in our project? What are the modules we developed, the pilots we conducted, and our work plan in general? What key exploitable results we produced from this project, and what kind of stakeholders and groups are liable to benefit from the work we've done. And finally, we'll talk about our pilot presentation, which will be this month. Okay. So what is the project? What is our Respondent project? As you know, we submitted this under the GNSS and Copernicus applications fostering the European Green Deal, as Ben mentioned. Respondent stands for Renewable Energy Sources, Power Forecasting and Synchronization for Smart Grid Networks Management. It's a 30-month project, Horizon Europe project, and with a budget of approximately 2.7 million. We started in November of 2022, and we're finishing actually at the end of April in 2025. So we just have another couple of months to go for our project. So we decided to come and address the following challenges with our proposal at the time. We know that the EU wants to be a climate neutral economy by the year 2050. Our Respondent project, we foresee will help increase the uptake of renewable energy sources, and this is crucial to contribute to the goals of the EU Green Deal. But we also know that renewable energy source power generation is very variable and highly weather dependent. So we decided that this kind of integration of renewable energy sources into legacy power grids could be difficult, and it could pose certain challenges and issues with respect to synchronization and supply-demand balancing. So therefore, in order to be able to integrate the renewable energy sources or the variable energy sources, what we propose in the Respondent project is a power generation forecasting module, which exploits local weather conditions and the Copernicus and takes in data from the Copernicus Climate Service, a power demand forecasting module, and also a monitoring of grids through the Galileo timing and synchronization service. So our exploitation of the European satellite technologies is twofold. One through the Copernicus remote sensing, and the second through the Galileo timing and synchronization. So all of these together form the Respondent solution suite. So our objectives were based on this, were to produce these three modules: to produce power generation forecasting, power demand forecasting, and to do a smart grid timing and synchronization by balancing the supply and the demand. And through this, be able to secure a seamless power supply and grid stability. So these are the three modules that the Respondent project consists of, as we said before. I won't go again into details. And what kind of methodology did we follow in order to achieve these results? We decided to follow a three-pronged approach, highly based on user input. So we had a lot of user interaction, both from within the project and outside of the project through invited stakeholders. And through this, we developed these three modules, gathering what were the most crucial needs of the users at the time, whether it be for the supply side or the demand side or the grid side. And through this, we developed the three modules and integrated them also. And in order to ensure that we were able to offer something that met the user requirements, we decided to validate our solutions through two pilot demonstrations, which I will talk about further along. So what are the modules that we developed, the pilots, and our overall work plan? So again, the power generation forecasting module, it utilizes the Copernicus Earth Observation Program and its advanced capabilities to estimate climate and weather forecasting. But in collaboration with the Earth observation data, we used also local weather station data to provide a more accurate picture of the ground truth regarding the weather forecasting. On the flip side, we developed the power demand forecasting module, which also considers weather data, but also historical consumption data and socioeconomic components, which currently don't exist in existing forecasting practices. And in the middle of these, the smart grid monitoring, timing and synchronization scheme, which utilizes the Galileo timing and synchronization service and exploits the Galileo differentiators. So these three together, integrated together, form the solution suite, the Respondent solution suite. It's complete software and hardware suite, offering both monitoring of the grid and predicted energy supply demand forecasting. So this is a complete solution suite. The benefits of this, it increases the timing and synchronization accuracy. It mitigates timing losses, interference, jamming, and spoofing vulnerabilities, and it fully exploits Copernicus Earth observation data for our forecastings. And in order to, as I said before, prove or validate our developments, our results, our project results, we decided to conduct two pilot demonstrations. A pilot one was focused on the power generation forecasting module. It already took place in Athens last October. And the purpose of this pilot was to validate this renewable energy source power forecasting AI ML algorithm that was developed under real conditions. So the pilot was collecting data, real data, live data at the time, and providing the forecasts. And our second pilot is coming up in a couple of weeks' time. And the second pilot will validate and demonstrate the full solution suite. So I will talk about that at the end of my presentation. Here are just a few snapshots or screenshots of our power generation forecasting solution. And my colleague Andreas will be providing a demonstration of this. And here are some more screenshots for the weather forecasting part. And this is a screenshot for the power generation forecasting part. And what kind of stakeholders are likely to benefit from our respondent solution? Obviously, renewable energy source aggregators, TSO, DSOs, grid regulators, PMU manufacturers, phased measurement unit, because we're using on our grid a Galileo-enabled phased measurement unit, and generally research and scientific community and society, of course, through the effect of being able to integrate more and more renewable energy sources and relying less and less on fossil fuels. So these are the key exploitable results. They just follow our developments, and these are the people or the partners of the project who would benefit or own from them, and the customers. So we already have a DSO in our consortium as well as res aggregators. And just to finish off with my presentation, I will talk about our final pilot demonstration, which will be held in Barcelona in Spain. So it's set to take place on the 27th of March. And the purpose of the second pilot or the final pilot of our project is to demonstrate the AI-driven power generation and demand forecasting and the Galileo-enabled PMU technology for real-time grid monitoring. So this includes an integration of nanosecond level time synchronization and accurate demand-side forecasting, and displays an independent EU-based time synchronization solution, which we've developed within our project. So I would like to invite anybody who's interested to follow our pilot. There's a possibility to come to the actual site, or you can follow online as well. And we'd be very happy if you could register. I'm sure Ben will provide the registration information for the pilot. And it's very near now, maybe within the next 2 weeks, 12 days or 2 weeks. So I'm very
just
happy.
To say, Effie, sorry, the date is actually the 28th. Sorry, that's a mistake. It's the 28th, yes. But I will definitely send out invitations to everyone present here.
That's wonderful. Thank you so much, Ben.